Hello students. Today we're going to look at graphing linear inequalities in one variable. So far we've only looked at equations, but now we're going to look at inequalities, and particularly algebraic inequalities in one variable. An algebraic inequality is an inequality that contains one or more variable terms. Let's look at some examples. Here's our first example. Do you recognize that symbol in the middle? This is the less than symbol. So we read this, x is less than 4. In this case, x is allowed to be any number that's less than 4, like 3 or 2 or -7 or even 3.99991. So in these sorts of situations, we're going to have more than one solution that fits the inequality. Let's look at some more examples, and let's look at some more inequality symbols. The next one I have is this one. Do you recognize this inequality symbol? This is the symbol that means greater than. So we would read this one, x is greater than -3. There are two more inequality symbols that we're going to look at, and I'm going to give you slightly more involved examples here of inequalities. The next one is going to be x plus 2 is, and we've got another symbol there. Do you recognize this symbol? This symbol means less than or equal to. It is a combination of a less than symbol and an equals symbol. This means that the left-hand side, x has to be something that makes it either less than 7 or equal to 7. And we've got one more. 2 times x minus 3 is, can you guess? The last symbol is going to be greater than or equal to. And here I'm going to write 3x plus 8. This is greater than or equal to. This means that the left-hand side is allowed to be greater than the right-hand side, but it's also allowed to be equal to the right-hand side. Now, just like we solved equations, we're going to solve inequalities, but that's something we're going to get to in the next lesson. Because first, we're going to look at graphing these inequalities. So just like with an equation where we had solutions to the equation, we're also going to have solutions to inequalities. And a solution to an inequality is a number that can be substituted into the variable to make the inequality true. It's very similar to a solution of an equation, but we're going to see things a little bit differently here. And we're actually going to make a table to look at various inequalities and their solutions. This is going to be a rather large table. So it's going to have 4 columns. First, we're going to have the inequality column. Then we're going to have the graph column. Then I'm going to write the alternate graph, or the alt graph, because there's 2 different ways to draw these graphs. And then finally, interval notation. All right. Let's jump in and look at an example of an inequality. Let's look at x is greater than or equal to 2. Now what I'm going to do is I'm going to draw a number line. 0, 2, 4, -2. Just part of a number line, of course. We know it goes on forever. And what I want us to do is I want us to plot solutions to this inequality on the number line. So we know that x is greater than or equal to 2. What are some numbers that are greater than or equal to 2? Well, some numbers that are greater than 2 are 3 and 4 and 5. Also, 2.5 is greater than 2. Pi, which is about 3.14, is greater than 2. In fact, any number that's to the right of 2 on the number line is greater than 2. There are an infinite number of those, so instead of putting an infinite number of dots, we're going to shade in the right side of the number line. Now, one more question. Is 2 itself a solution? In this case, it is, because x is allowed to be greater than or equal to 2. To express that, what we do is we put a closed circle on the 2 to say, yes, 2 is allowed to be a solution. Now, before we move on to the alternate graph and interval notation, I want to actually start another example so we can compare and contrast. Let's look at the inequality x is greater than 2. Again, I'm going to draw a number line. It's not perfect. When you do problems in WebAssign, the number line will be provided. If you ever need to do number lines on a written test, do your best. Use a ruler if possible to draw a straight line. So here we have x is greater than 2. Now here we're looking for numbers that are larger than 2. Still, it's true that 3, 4, and 5 are solutions. 2.5 is a solution. Pi is a solution. It is still true that all the numbers to the right of 2 on the number line are solutions. But the difference here is that 2 itself is not a solution, because x has to be strictly greater than 2. The way that we represent that is we put an open circle around 2. What that communicates here is that the solutions end at 2. It's everything to the right of 2. But because it's open, that communicates that 2 is not a solution. All right, so we have two graphs. We've got x is greater than or equal to 2, and x is equal to 2. I want to now jump to the next column, alternate graph, because there's another way to draw these graphs. There's two ways that different books cover these. Now, we know that a closed circle represents a situation where it's allowed to be equal. There's another way of doing this. We can use a bracket. This is just another way to represent that endpoint is a solution. So we still shade to the right, but we use a bracket. We also have an alternate way to represent an open circle. Instead of an open circle, we can put a parenthesis. This is just another way of doing it. Some books choose open and closed circles. Others choose brackets and parentheses. It's your choice. I will accept either. WebAssign will accept either. All right, we're going to do two more examples of inequalities, and then we're going to look at interval notation for all of these. Let's look at x is less than or equal to 2, and x is less than 2. Where on the number line should the solutions fall to these? Well, if we're looking for numbers that are less than 2, those are going to be to the left of 2 on the number line. Those are 1, 0, -1, etc. So we shade to the left of 2. Now here, 2 is a solution, so we're going to use a closed circle. In the other one, though, x is less than 2, 2 is not a solution, so we're going to use an open circle. All right. We're going to continue this in the next video because this video is getting a little bit long.